Can everyone can see my screen now?
Yes.
Okay. Okay, I'm executing the function. Okay, I'm writing the function here. I'm executing the output here. So the recursion itself, you have two main things. Okay, first one is the base condition. It says when to stop. The second one is the recursive. Case it will call the function again. So these are the two main things we have to deal with. First of all, we start with a very easy thing, sum function. Okay. It takes a list. Okay. So how I am defining the base condition, or how I am defining the recursive condition is almost based on one on each other. So first of all, I start with the recursive condition case. Okay. What I am returning. I am taking the first element. Okay. I am calling the same function with the except first element. Okay. So what will happen if I execute this function without the base case? Can any one of you tell me what will happen?
Infinite loop.
Yes.
Infinite loop.
Yes, kind of infinite loop. It's kind of infinite recursion happens. Okay, I have to call the function. Okay, I'm getting the recursion. Okay, yeah. At the end, I'm getting that somewhat it prevented the recursion error because it haven't gone through that much time. It said the list becomes empty, so it throw an index error. Okay, we'll see. Okay, now I'm giving the base case when I have to stop. Just note the point. In each time, I'm taking out the first value. I'm passing only the rest of the elements of the array. I mean elements of the list. Okay. So at some end, this list becomes empty. Okay. Now I have to take care of that. So the base case, what I am defining is if length of L is equal to 0, then I'm returning 0. We'll run that and see. That's messy.
Sir, you're not printing the output.
Yeah, actually, yes. Yeah. Same way I can do 0 as well. Okay. You got understood this thing, right? How we are calculating the sum through recursion. Okay. I'm just going to do some changes here. Can we implement in some other way? Let's say I'm taking only up to the last element. I'm taking the first element and the last element, and I'm passing the in-between list to the function. Same. Yes, Prava. It's returning the wrong value because it's if I pass an odd number, LR0 and LR-1 will be the same. So in that case, it will work. Yeah. So what I have to do is,
If it is 1, we can simply return a single value.
yes. Yeah, that also works. Yeah, that's
For even numbers, so you will need a 0 condition also, because after last one, the len will become 0. Then
yeah, we have to add a more thing. Yes. It can be after crossing this line, right? It can be either 0 or 1. 2 won't be occurring because if the 2 occurs, it will become 0 after that. So okay. Okay. These are the primary things. These are the base conditions. These are the recursive case. It is for a simple sum function. Okay. Now we start with the Fibonacci sequence. Okay.
Won't else be required here?
Here, not much. I mean, it won't change anything.
Okay.
I mean, when we get this thing right, either it will have because of the return statements. Once the control reaches the return, nothing will execute so far after that. So it won't else is not required.
Okay.
Sir, I'm a bit confused why we took plus L minus 1 at the end.
Okay. Initially, I took the first element, right?
Yes.
Then I gave the rest of the list to call as a parameter, as an argument to call itself. Okay.
That's our recursive part, right?
Yes, yes. That's a one way of approach. One approach. Another approach. I'm just modify the function. I took the first. I took the last, and I took the. I mean, I'm giving the rest of the element, which is second to the penultimate one, penultimate element, to the same function. So based on the recursive case, we have to change the base conditions. That is how we want to say.
So when we have these three terms in the recursive part, that's when we have to write length of L is equal to 0. Otherwise, when you didn't have the last element of the list, it was enough to have the base condition with only a length of L is equal
Yes,
to
yes. Yeah, the reason is because okay, we'll consider this case. Okay, at some way I'm calling like a sum of one. I mean, I'm passing simply sum of one. Okay, only one element is there. When I give the sum, so it will becomes the value becomes L of 0 becomes 1. So similarly, L of minus 1 also becomes 1. So
why is L of minus 1 1? I didn't get that.
okay, L of minus, okay, here L of minus 1 is the last element. So if it's only
Yes.
one element in the list, right? The first element and the last element are
Yeah.
the same, right?
Yes.
So that we have to take care of it. Okay, even in that case, that it will result a wrong answer, I suppose. Okay. We are handling it. Okay. So in the recursive case, uh, we are giving a L of minus 1. The same value is repeated and again, right? So to prevent that, if we are having only one element, then we are returning returning the itself. If there is no
Yes.
element, okay, that case comes the first case, right? It will execute when for the example, simply one element or any odd number of elements. Okay. Another case.
Maybe we can just take one element. Yeah.
Yes. I mean, here is the one element case, right?
Yeah.
Here it's a two element case. If here the last element L of minus 1 is 2. Okay. So what will happen is L of 0 will go here, L of last minus 1, the last element will go here. Here it goes to an empty list.
Yes.
Okay.
If it's a single element.
Yes. If it's a two element, okay. Here I mean L is equal to 1 comma 2.
Oh, so 2.
L of 0 is 1.
1.
L of minus 1, which is the last element, 2.
Yes.
1 to minus 1. It is an empty list.
Yes.
Okay. So here we are passing an empty list. So that condition is checked here. I'm checking for the length of L. So length of empty list is 0. So that I'm checking here. So I'm returning 0. The returning 0 is based on the operation we are doing. Okay. So here I am doing an additional operation. So it will, the adding a 0 will not affect anything.
Hmm.
So I'm returning
If it
0.
was,
If it's a multiplication or anything, we have to have
then
somehow like I'm calculating the factorial. Then we have to have a then we will be returning 1. I mean, it should not change the result.
would we have gotten the same result if we hadn't added in the recursive part L of minus 1?
Yes, same. I mean, it's not the same thing can do it. Yeah. We'll be getting the same.
So I think
Yeah, we have to change the.
And yeah.
that
No, minus 1.
Yes, Hassan or any doubt?
Yeah.
Okay. Here's one another way. I mean, it's the simplest way. I'm saying there is more than one way of doing the same thing. That's it. I mean,
Yeah.
the based on the recursive case, right? The base condition will change. That's all. That's I want to convey. Okay. You understood this part, right? How we are doing the sum.
Yeah, actually, recursion is a little difficult. It takes some time to visualize and understand what it's actually doing.
Okay. Yeah, it will. I mean, I'll give you a small like a verbal explanation. Okay. Just read this text. Okay. Just read the English text. Can you able to identify what's going on here? So what I'm saying is just wait for 5 more minutes. Okay. Then come back and after that come back and read the text again until I come. So here is this until I come, right? It is the base case. In a regular day scenario. So wait for 5 more minutes and come back and read this. This is the recursive case.
Okay.
Are you able to interpret and understand what's going on? I mean, this is a very basic thing. If you have any doubts, just let me know. I'll explain it more.
No, it's fine.
You understood, right?
Yeah.
Okay. Fibonacci sequence. So how generally we calculate the Fibonacci sequence is we take the two initial numbers 0, 0 or 1, or we can start with any of the number. We add the last two number and we'll get the value, right? So that's what we are doing here. We are going to do here. So first of all, I'm going to write the base case. So when I have to stop, okay. So just note that so mathematically, if I wrote Fibonacci of n is equal to, let's say, Fibonacci of n minus 1 plus n plus 1. Okay.
Is it recursion, sir? Sorry, I joined late.
Yes, it's entirely recursion.
Okay.
Yeah. So here's the case. So we are referring the same function based on itself. So the main thing we have to note is here we are dependent on two numbers. I mean two previous values. Okay. So I'm going to write the base case first. If I'm starting with a sequence of 0 and 1. Okay, I'm following, for me, the Fibonacci sequence is 0, first number is 0, second number is 1. We can start with either 1, 1 or anything is fine. So if n equal to 1 or 0, return 0. Okay, if n equal to 1, return 1. Okay. So instead of writing this, okay, yeah, we'll go with it. And the recursive case was return Fibonacci sequence of n minus 1 plus n minus 2.
Sir, n equal to 0.
Yeah, sorry. Okay, it's giving the correct answer. So based on that, here is the index. It will be the 0, 1, 2, 3, 5.
Sir, I have one question here.
Yeah.
When n not will be not equal to 0 and 1, then only the 11 line 11 it will be executed, right? When it is not 0 and 1.
Are you telling about this line? Then?
Yes.
This line?
Yes.
Okay. Okay. I am even simplifying these two lines, sir. Okay. So I'm simply saying if n equal to 0 or n equal to 1, simply return n. Just a simplification. That's it.
Okay.
So the value is good. First of all, we have understood the relation between the recursive case and how we are handling in the base case. That's all. Any doubt?
Sir, please explain the line 3, return FIBN minus 1 plus return FIBN minus 2. How this is
Okay.
like the loop I cannot understand.
Okay. Let's say n of I. Okay. I'll write it down. Just a minute.
Hello, sir.
Yes, I'm.
Sir, what if I am taking n is a negative value?
Then it will throw. Actually, the code will collapse. Actually, in that case. So this is how we are calculating. The thing is, we will be setting the first two numbers. This two number is always set. Okay. So by now, I mean, we always know if n equal to 0. I mean, yeah, let's say n is the index parameter. 0, it is the number we are given. 1, this is the number. So this is the base case. So Fibonacci sequence for a -1 does not exist, but programmatically here it will go like a.
So base case means here the loop will be terminated, right?
Yes, here the loop will be terminated, but if it's a negative number we are passing, right, it will not reach this case. So it will continue to go beyond the minus value. It will go on infinite recursion.
So how can you handle it? Negative value.
Okay.
Okay.
Return none or something. We can throw some errors.
Return 0.
Yeah.
Okay, sir. Okay.
So because of the I gave print, so it printed the none. I printed provide positive value. This is one way. Always the another one thing is for a debugging thing, right? You can always print the first line or the number, I mean, whatever the arguments you are passing. So it here in the negative value, it's a simply one case. Directly checks for the first time itself. So we go with 5. You can see it 5, 4, 3, 2, 1, 0, 1, 0. I mean, at first it will be like a what is the random sequence? I mean, there is not much sequence, right? But in the sum, if you have seen it, right, it is in a sum order, but it's somewhat irrelevant, right? So that's how we are going to see. Okay. So these are the base condition. Any doubt in the base condition?
No, sir, not
No,
in the
sir.
base condition.
Not
But in the loop.
condition, right?
In the loop, sir.
Okay.
How this loop is
Okay. That
rotating.
Yes. Okay. Fibonacci of 5. That is what we are taking. So what it will call, right? It will call just note down n minus 1. Okay. Here it is, the base condition is totally false. So these things will not happen. So it will call Fibonacci of 4. And Fibonacci of 3. So this is the first one, the n minus 1. So we can go even like that. I mean, if the Fibonacci of 4 will call the Fib of 3. So another one is here. I'm not calling because n minus 1 I'm not going there because it won't be called. It will call Fib of 2. It will call Fib of 1.
1. Then
And
the Fib of 1 is
Fib
1.
of 1 directly we are getting the value. So it will further will not call anything. So it will call Fib of 0. Okay. Now we got the value. I'm writing the sum of the value here. 1. Okay. So we got that value. I mean this region for Fib of 3 is done. So again we are going.
Sir, here I have one question.
Yeah.
Fib of 1 value of fib of 1 is 1, right?
Yes.
But
But
how
value,
to get fib of 4 or fib of 3? How to get the value
yes,
of
yes, that's what I'm going. Okay. So it is the procedure. Okay. Just go. Just be patient, and you will be know.
okay.
Okay. In this fib of 3 case, right? We got this fib of 2 value on the second thing. Here we have to get the fib of n minus 1. So here in the case fib of 1. Okay. So fib of 1 will be getting the answer directly. Okay. It is 1. So here fib of 3, that Fibonacci of n minus 1 plus n minus 2. So we are adding this one, it will be 2. Fib of 3 is 2. You understood, right? So then again, the fib of 4 will call fib of 3 and fib of 2. Again, this will call 2 more function, fib of 1 and fib of 0. Fib of 1 will return 1, 0 will return 0. This value, the addition will get the value 1. So we got this part. For Fibonacci of 4, we got the Fibonacci of 3, Fibonacci of 2. Now we can go in here, we'll get the sum. The sum will be 3. Same. Again, then we calculated the Fibonacci of 4. Now we have to calculate the Fibonacci of 3. So it will keep on going. The same thing. You can see the pattern, right? This Fibonacci of 3 will be exactly like that. But we are calculating it. So it will be
why is it returning Fibonacci of 1 as 1? Means where have we mentioned that?
here.
So but n, okay.
N equal, I mean, in simplicity, I wrote this as if n equal to 0 or n equal to 1, return n. Okay.
So you mean to say when it comes from 5 to 4, it doesn't calculate, doesn't go to fib of 4, then it goes to fib of 3, then down, and then at
Yes,
2
yes,
it
yes.
calculates the 2. It takes
Yes.
the 2 steps.
Yes, yes. Based on the, because we are calling the Fibonacci function n minus 1, right? It will call the function itself, but it will not calculate this part. It will not go to that part.
It will know only on the last step where the
yes. The thing is, when you get this part, right? When you get this value, then only it go to the next part.
okay.
So that it's happening. I mean, the left side is happening. Left side in the sense here with respect to n minus 1. So finally, we got the answer 5, which is returned. Okay. Now we'll print this thing. Okay. What I wrote. Right? Now we.
So can you please explain it again once again, sir?
Okay.
This is the confusing part. So can you explain it much clearer, sir?
Yes,
Sir, if you could give with this example, if you could give some other example also, that will be helpful.
yeah. Okay, sure. Okay, we'll start with the sum. Okay. How I wrote the sum is for sum. It is L. Sum of okay. Take the first element and go with the rest. Okay. So I'll take the L is equal to 3, 4. Okay. And So what it does is it takes the first part L of 0 plus sum of L. L of 0 is 1, and for the sum it calculates okay. So that will be state again this sum. It takes the first element and calls itself with the value 314. Again, okay, I forgot the end condition. Let's say I'm going with a empty list. Then
Means while L length L greater than 0,
yes,
right?
is equal to 0.
This condition.
Okay. Empty list. Okay, I'm writing the answer in green. Okay, this will return 0.
Please scroll up a little bit. You cannot see the below part.
Okay, can you able to see now?
Yes, sir. Yes.
So the answer is for sum of empty list is 0 that we have defined here. Okay, so this part, for this part the returned value is 4 plus 0, answer is 4. Okay, so 3 is here. Any doubt here so far? So we are going back.
So means it is collecting the value
Yes.
in each step, and
Yes.
then it is doing the sum.
Yes, but if you are doing the recursion, right, it is sorry, if you are doing iterations, the work is totally different. I'm going through the iteration as well next. Okay, so 4 plus 3, the value is 7 here. So 7 plus 2, 9. 9 plus 1, here it's 10. That will, this is returned. Okay.
Sir, is there any easier trick to write these recursion problems?
No, there is no trick. The thing is, you have to understand the problem, what is going on. Else, recursion will be a really tricky. I mean, it's really time consuming. If we don't understand what is happening, recursion will be very difficult.
Can we solve some harder problems in the practice assignment there?
Yeah. I mean, you go with them, go with the problem. The thing is, before solving any problem, just understand what is happening. Okay. Okay. Just I will go here and I write the recursion problem in a somewhat mathematical way. Okay. Sum of them. I mean, it's not a pure mathematical way or anything, something just to be understandable. It will be L. Okay, this is the condition we are doing that. Okay, so let's say we go with the iteration. Okay, you understood what we are doing here, right?
Yes, sir.
So it's not a pure mathematical way, but just for our understanding. Okay, the same thing, iteration. I'm initializing a variable called sum equal to 0. Okay. If the length of L is greater than 1 or so, greater than 0, I'm continuing with this. Okay. You understood, right? What is happening? Finally, I'm getting the value. And that's all. Any doubt here? How we
So
are doing?
sum is equal to sum plus L of 0.
Sorry.
Yeah. Sum equal to sum plus L of 0. Yeah, thanks for finding out. Okay. How it happens, right? Initially, sum will be 0. The same thing will take. The first iteration, it's iteration number 0. It will go and the sum becomes first 1. Here I write the sum value. Here I write the value of L. Here I am passing the argument. The sum will become 1, the first value. The length L will become through 2, 3, and 4. Sum will become 3. So it is an empty list. It will not. The loop will not come. Okay. The thing is, here we are going by one, but whatever we are doing here, right? It will not call itself. I mean, it will not call the function itself. It is a very standard iterative process. Irrespective of the function, you cannot here we cannot say base case or anything. Under certain condition, it will stop. Okay. But here, whatever you are have, let's say, okay, in some case, okay, after this iteration, some error happened. What is the value of sum? I mean, this after this one, before the execution of 2 or something, some error happened. So the system halted after that. What will be the value of sum? 3, right? Okay. But same thing. Let's say here something happened, it gone off. What is the value of sum? What is the value of you want to be returned?
Zero.
No, actually the thing is, we don't know. The way we define this 2 plus sum of this value, right? It somehow entered in error or doesn't return the anything or anything like that. In that case, we don't know. We cannot add, let's say, we don't know this value, so it will be halted. I mean, I don't know what to add with the 2. You understood the logic?
That means it runs through the whole program, the
Yes.
whole iteration, and then it calculates backward.
Yes. Until it reaches the last base case, here it is a return statement, so it is going back and back and back. Okay. So it has to come back. Until it come back to the initial stage, this have to return. It will not, you won't get any solid value or anything, any solid result or anything. But in the iteration case, it's not, it is totally different. I mean, it is halted in a halfway, okay, but you have something. I mean, if it got any error or something, so for some reason your program got stopped, but somehow you stored all your values, then you have something, some results you have. But if it's a iteration, so if it's a recursion, you don't have anything. I mean, based on the result. I mean,
Means one thing from my side. So in recursion, it is going from back to forth, and in iteration, it is going from top to bottom, right?
yes, kind of. I mean, here in this case, it is going in the values. You need to know that.
Yes.
Okay. I mean, here the value will go back. I'll give you another case. The value will not go back. Okay. Here we are giving the value back. Okay. So I'm giving another thing.
This one thing. While going from sum of list 4 to sum of list 1, it is collecting the value, right? Like
yes.
4, first it collect 1, then it collect 2, then it collect 3.
Yes.
Then when sum of L, then it collect 1, it collect 4, the last value.
Yes.
Then when list will be empty, then it will go back, and it will add all those values, right? In this way, it does what?
Yes, the same. I mean,
I think it will iterate till the base condition is reached, and then from that,
yes.
After that,
the thing is, for every time you have to evaluate the sum. Okay, the evaluation is method. I mean, for this case, okay, the evaluation is L of 0 plus sum of remaining rest of the array. That is the evaluation condition we have. How to evaluate the sum? This is the case. How to evaluate this empty list? Okay. So if I'm simply said, if it's an empty list, it will return 0. That's all. In otherwise case. Okay. So every time it has to evaluate itself. The definition is based on itself. Okay, I'll show another easy, very simple example. I'll write the code itself directly. Okay, what I'm going to do is I want to find the last element of the list. Okay, it simply returns the last element. That's all. But I know the length element, length function, all those things. Assume the case I'm giving only the length will be always positive. So Okay, just read this problem and let me know what does it do. Okay, it simply returns the last list. In this case, just say it, we are not taking anything back.
Could not understand, sir.
Okay. The thing is, how I define this, if the length of the list is 1, okay, return the first element.
Yes.
Okay. If that is not the case, or else let's say else, in the simpler understanding, we say else, okay, just to easy to understand. If that is not the case, call the function itself without the first element. Okay, so we go by line. Okay, so I'm taking the length element first. I'm checking the condition. So it is 1. Whether it is length is not 1, so length is 4. So I'm go. This condition is false. So I'm going to else bar. Then I'm calling the function itself with the without the first element. I'll show. Calls itself because the condition is the length is not 1, so with 2, 3, and 4. So again it calls itself because the base condition is not satisfied. Three and 4. You understood what I'm writing, right? Anyone?
Yes. Yes.
Haven't understood what I okay. It is 4. So it will return the value 4. That's all. Return L of 0. This is the first element of the list. So return 4. That's all. We are not taking anything back. We are simply returning that value.
Okay.
But how it returned? That's the thing. It is not coming directly out of this last level. Okay. Okay, I'm explaining it again. It is before we got. But it will go here. Okay. The last element of 3 or 4, that will evaluate to 4. That gave the same 4. That gave the same 4. Then it cuts out.
So can you repeat please the last thing? How
Okay.
4 is you are getting everything?
Okay. When we get the 4, right? You understood from here, right?
Yes, 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 yes.
Okay. This is evaluator. It returns the value for this value. At the
Yes.
last end, it returns the value 4.
Yes.
So it will go back to the previous function.
Yes.
Okay. So it will go as a value as 4. Then 4 is returned. Okay. Then that go back. Okay. That return, it will go back as a single value. We are not computing anything.
Sir, one thing here from the last line, like only when 4 is there from the list 3 of 3, 4, how it is getting 4? Like it in the first, it says when length of L is 1, then only return L0. Means when one element is there, then only we take that element, like 4.
Okay.
But when more than one element is there, how every time you are getting same element 4?
Yeah. Okay.
The last element 3, 4, the return is 4. That is why it is
Yeah.
returning 4.
We are not computing anything. We are not adding it to itself. The reason here it is changing, right? Because the value is changing because we are adding some number here.
Yes.
Because of that, that value is changing. Here we are not changing anything. Okay. Just the code itself I wrote like that. Whatever I wrote in the code, right? I'm not going to do the same thing, but I'm going to write in a function way. Here it is false. Okay. So this condition will not execute. It will go to this value.
Yes.
But so it in terms calls the last element. I'm just writing as a def. So just it's not that I'm not going to define or anything. Okay, I can remove just no, okay. So how it is like it will be like 2, 3, and 4. Okay. So again the condition is false.
False. It will
The
go
thing
to
is
else.
it is not completed yet. It is calling here.
So 3, 4, 5.
Okay. Again it calls
4 only.
4, but here the condition is true.
Yes.
So instead of going here, it returns the value 0. Sorry, it returns the value 4.
4, yes.
Returns 4. Okay. So what it will replace is here this value, right? It is evaluated to 4. Sorry, can you able to imagine it or?
Sir, at that point only I get the second last there I'm getting.
You are it is written in
yeah
false.
That is fine. The last one is fine.
Okay. I'll do. Okay, I'll explain you once again. Just here. How it works, right? Okay, let's say we have just assume some function. How it works is that value. Okay, yes, equal to sum of the sum list. Okay, you understand? Everyone knows this function, right?
Yes.
How the computer does is, let's say, just imagine that way. It will calculate the sum and replace the value here like this.
Okay.
I mean, that particular function will return a value that will occupy that position, kind of thing. So you understand this one, right?
Yes.
How it is happening? That this is the value is getting this. I mean, 3 is the value returned here. So it will occupy this place. Okay. In that same logic, so it called this function, right? That one. Okay, actually, I should have replaced here. So it will call 2, 3, and 4. Here it will call 3 and 4. Here it will call 4. Okay. Right. So what is L of 4? I mean, last element of L of 4. 4, right?
Yes.
So I am returning 4. Okay. What is the last element of
this value, I mean list which have 3 and 4.
4. Okay, I got it, sir. I got it.
Okay.
Yes,
The
sir.
same way.
Yes, sir. It took me very long. Yeah,
I
I
mean,
got it.
initially it's a little hard to imagine what's going on.
Yes, sir.
So finally, we got the value as 4. The thing is, in the Fibonacci sequence or sum, we calculated something. I mean, along with the 4, there is something to add or anything. Okay. Here in
Yes,
this
sir.
case, it is not there. That's
Yes,
all.
sir.
We are returning the same value. We are taking back.
Right.
If I haven't given the same value, okay, let's say I delete this thing. This is not good. Okay. What will happen? Okay. If I remove the return statement, I can execute the function itself. The answer is none. Can anyone say how it is none?
Because it's not returning anything.
Yes, exactly. The thing is, it is doing all the recursion. It is doing the recursion. I can print the value, but it is not returning anything. Okay, I'm printing the L. Okay, so just see. The thing is, it is first it was all the entire list. After on the second calling, it's 2, 3, 4, 3, 4, and 4. When it got 4, this condition was satisfied. Okay.
Yes, sir.
But it returned 4. But we are not returning that to the back to the function. Okay. We are not returning that 4 to back. So because of we haven't introduced a return. So it says it is a none. I mean, we haven't returned anything. So that none will be got back and back. So in the end, it will say none. Say here in this sense. It will be evaluated to, yeah. It says simply yes, but I haven't returned it. So it says here also it will be evaluated to 4. That's all. But I haven't returned anything. So if we didn't return anything, that function will by default return none. That's all. Then that will go back. That's all.
So how to solve factorial?
Factorial. Okay. You understood, right? How we are doing,
Yeah.
how it's getting back. Right?
Yeah.
Okay. Okay, the base case is if n equal to 1, I'm returning 1. Yes, I will be returning times 1 factor n minus 1. Check those. Okay. How it works is, if the n is equal to 1, I'm simply returning 1. Okay. But if it is not, that condition is not satisfied, I am multiplying the n with the factorial of n minus 1. Okay, we'll write it.
Yeah.
Yep. N is 0, so all condition is 0, right?
Yes, it will be 0, but it should be actually it should not be 0. 0 factorial is 1, so it should be, yeah. So it will call factorial of 4. 3 and 3 times factorial of 1, but if it's 1, it will be evaluated to 1. So the factorial of 2 will be 2. So we know the factorial of 3, which is 6. 24, and again it will back to 120. Okay. Any doubt, or should I explain one more time?
Please give 1 minute to understand. Then
I'll write it.
Excuse me, sir.
Yeah.
Sir, after this, will you please explain PPA6?
Yeah, yeah, sure.
yes, it is clear, sir.
It is clear, right?
Yes. Sir, only one thing.
Yeah.
Here return n multiply fact n minus 1. So here while it is going from down to up, it is taking the value and it is doing the multiplication. And in the last day, in the last problem, it was not doing any like only like any doing, it was only taking the value,
Yes.
right? No,
Yes,
not
yes.
doing
It
any
is not
addition,
doing
subtraction,
yes.
like and not doing anything.
Yes, it is not manipulating the returned value.
Yes, yes, yes.
Once we got the returned value, we are simply giving it back. That's all.
Yeah, every time,
Yes.
only the value. Oh, yes, I got it.
Okay. I mean, these are the very thing, and all we have to know is how we are formulating the base case, how we are formulating the recursive case. These are codependent. Okay. Just concentrate on the base case, and I mean, these returning fact is it's kind of like a silly mistake we usually do because we don't know what is happening. Okay. I mean, in general, if we don't know what is, I mean, when we don't know how recursion works, that is the silly mistake we do. But after we know, so now we know how to return it back. Okay. What is the significance of returning the value? How it got back? Now our focus should be mainly on how we are finding the base case and how we are returning case. Yeah, recursion case. Okay. Clear, right?
Sir, one thing, there should be one else, right? If and
I mean, yes. I mean, it else also works.
Yeah, because
it
now
not
everything will
mandatory.
be in the if loop. Then, if not else is mentioned, then
I
everything
mean,
will be.
it is not mandatory.
Okay.
The thing is, it is not mandatory because I used return here. Okay. If I am using either, if I'm using if else, right, it can be a either or.
Yes, yes. Because I have also seen in definition only one return, we get the value of only one return, not two. Like
yes. When it goes to this return,
first,
nothing
yeah.
below will execute. It will-
Nothing below is yes,
Yes.
right.
But if it's a not else, if the condition is satisfied, it will come here. Otherwise, the second also works.
Okay.
Yeah, but because of the return, it's fine. I mean, we are writing in a very short form, so that's why, yeah, it seems simple. With respect to this case, return else also works. Okay. Somebody asked to look into a PPA, right? Which problem?
We
It's
need PPA 6.
Okay. So it's like I'm starting from a point. So I'm going up to the distance like r minus L. Okay. Now above spiral. Then I'm coming to the midpoint of r minus L by 2.
Right.
Okay. So then the same thing happening again. Now what the position that L had is r minus L by 2. That is the same. Now again doing the same thing. Okay. Right. X coordinate. So it's an infinite recursion. Actually, there is no into it. So we are stopping after some number. Okay, number. Okay.
So left one will simply be the right value and right will be the division of 2. Addition divided by 2.
Yeah.
So while condition will be while n is not equal to 1.
Sorry, while n not equal to 1. Once it's okay. Okay, right. Yeah, sometimes 2 minutes. Okay, yeah, actually it's getting 0.5 directly.
So the condition will be while it is not equal to 1.
Actually, the
Sir, we should put the condition for I in range n minus 1.
yeah, but actually the thing is when we are going through iteration, right? So we are doing like 9 times, okay? Sorry, n times. So after in the iterative case, if I put for or while, it doesn't matter.
So the condition should be n minus 1. It
Okay.
will work.
Okay, okay. Here you are saying. Okay. But it's also give n minus 1 value, right? Let's say if I want 5 values, okay? So range of 5 will give the 5 values. 5 number of values. Let's say n minus 1 in the sense 4 will give only 4 number of values. So in that case, it's fine. The thing is, it should be a
So can you just show the second function too?
recursion.
Yes, sir.
Yeah, actually, I was not able to solve this one.
We are getting the left only.
Sir,
Yeah, in that case, it will be a simply right. And the -1.
So can you zoom in?
So how its right is changing? It's coming to the point L -2.
Sir, we should return right, not left.
Doesn't. Right? No, it won't. No, it doesn't matter. I mean, here we are getting another issue. Okay, actually the function is returning none. That's the problem here. Okay, let's see.
hello, sir.
Yeah.
Sir, actually, for the recursion week 8, the submission date is tomorrow. But sir, within like this much short span, it is
No,
impossible
it's
to.
the only practice problem, right?
So just last
GRP,
one thing, sir.
for GRP and everything.
Yeah.
29.
Sir, in this question,
yeah,
can we put if n equals to 1 and then return right?
okay, it doesn't. I mean, it doesn't matter, right? At the end, it has to return something. I mean, actually, it's returning a none type, so something else is happening. That's
Sir, it should be right plus left, not minus.
Actually, yeah. Actually,
Yes, sir. Yes, sir. Right plus
and-
left.
No, it's left plus this thing.
So
Yeah,
since we're taking the
correct,
midpoint,
yeah.
so
Yeah.
So we have to return the midpoint, so it should be right plus left.
I also made the
Yeah.
same mistake because I was considering coordinates.
Yeah. Sorry, actually, I'm looking into the iterative questions. Okay. Yeah. Yeah, correct. Yeah, it should be like a left plus right minus left by 2. So it will be right plus left. Yeah. But this kind of question is easier to solve if you are using recursion. The thing is, you know what is the recursion is like a more like a declarative. Okay. You know what it comes, right? This part and what it comes to this part. So you can simply plug it in and you know the base case, you can be solving it directly. So now we go with the iterative case.
Okay. Have you understood what mistake we did so far? We need a temporary variable here because when I assign the value to the left, it will be won't there be I lost the value of the left, but I need the value of left itself. So I have to store it in a temporary variable. Then I have to assign it.
Excuse me, sir.
Yeah.
So I'm not getting that how you are returning like right. What's the logic? Like n equals to 1 then right.
Okay, the L is the left, okay, left. L means
Yeah.
left, R means right. These are like a simply X coordinate, that's all. L is a X, L is a left and R is a right coordinate, okay. So once we reach here, the next coordinate is, between the point. Just 1 minute. Okay, the thing is you have two values. The whatever the point, let's say you have 2 points, okay, first point and second point. The third point is in between that point, in between the last 2 points.
Yes.
Okay, I'll write it in a sequential manner, it will be easier. It is PPS 6, right? The third point is between this point, between these 2 points. So it's 0.5. Again, below the 2 point, so it's 1.5. So it goes on.
So from where is this 1.5 came?
1 point is the last sum of last 2.
kind of like that. Initially it was 0. Okay, in the first run, the left was 0, the right was 1. Okay, the right is equal to midpoint of left plus right, so it's 1.5. The same 1.5 by 2, 0.75, 0.75 plus 0.65, 0.5. Any doubt? If you don't worry about that this much, okay. So the thing is, with respect to recursion, right? It's more stuff like straightforward. All you have to know is find the base case and recursive case. That's all.
Sir, what about PPA 15? Can we solve?
Yeah, 15. Okay. Actually, we have a list of coins. Okay. It's simply like you have to find the subset sum of subset. So the sum is yes. Actually, it's quite a like a you have to. It's quite challenging somehow. Okay, got it. Something I have left, but most of the private public test cases were passed.
So if already S is present in the list, that can be the case.
Okay, somehow I missed it.
So if S is already present in the list.
Present in the list. Yeah, that one may, but that also satisfies this condition. Whatever I wrote, right, it will satisfy that condition. It will go through. I go through all the elements. At the beginning of the element, S of L minus L of I, S minus L of I, right? It will satisfy that condition if S is in the list. The another thing is the length of L is 0 that I counted off.
Sir, what is the number of program?
PPA 15. Okay. Yeah, PPA 15.
Okay, sir.
Yeah.
Sir, how do you even get the idea for writing this code, sir? Not understanding.
Okay, I'll explain that. Okay. Okay.
Especially
somehow
this week, most of the programs feel like that only. Like
no. I mean, everyone takes some time. Okay, even me, anyone. Okay.
but we don't have time now. It's only one.
No. You have to invest that time. I mean, that helps. Okay. I mean, for a beginner, it will take a lot of time. Once you learn it, right? Once you learn the recursion, I mean, things will become very simple. I mean, easy to write a program. I mean, when you see that pattern occurs, right? Instead of going through iterative loop, if you are using recursion, it's much more easier. I mean, easier to interpret. Okay, I'll explain what I wrote here. Okay.
So is all private cases has passed?
No. Only one I missed.
Yes.
14 out of 15 I passed. Oh, now I missed more. Okay, here's that's all. Putting out of 15 passed. Somehow I missed one. I checked for the length condition and I checked for the negative value as well. If the value was negative, that also I check. The true only occurs when the s equal to true.
So there should be one more else condition in the last for loop. Like
Not required. The thing
that
is,
one return
no.
subset of some
No, it
from
is
L
it
of
is
minus
totally
1 to
correct. I mean, it's totally correct. Why I'm saying right, when it crosses the final last element of the list and the last possibilities, right? Then it will. I mean, after that it didn't find any sum. Then it is totally false. That I'm sure.
So in the last one, it will give you out of index error when I will reach because you're adding +1.
Well, yes. Here it will go.
So
Because I am taking from the index, right? So it will be, but if I
so
add +1, it will go out of index error.
yeah, so I +1 it will go out of index, no? The last element. When I text the last value, it will go out of index for the L for the second element in the subset. Li
Yes,
plus.
no, it's supposed to. The reason is I am taking out of that element, okay? Then I'm not including that for the sum.
But then that is going to throw you an error, no? So
okay, got it. So no, it will return an empty list only. No, nothing. Okay, yeah. Somehow I passed 14 out of 15. It's fine. Okay, I'll tell what it is going on. Okay. I mean, it's really hard to understand, even if you don't understand this. I mean, using a for loop in recursion, don't worry about that. You'll be learning about this when you come to PDS. So don't. Okay, I'll start with a fewer numbers, because it will go on recursion tremendously. I'll copy the code. Okay. These are the base cases, okay? This part and this part. And it is also a base case. Because I'm checking whether it is in anywhere it returned true. So these are all the base case. The main recursive case is
So
this block.
how can if s equal to 0 then it will return true?
It, and let's say if somehow if any of the value returned true, right? If anywhere if if anywhere in the any combination is evaluated as true, then R equal to true. If true, return true.
So second statement, if S equal to 0, then return true.
Oh, okay. The thing is, whenever I took an element, right? I mean, then I'm minusing from the S. Okay. At the end, let's say I'll go with it. Okay. At the end, it will become 0. Let's say I want to find the sum which is equal to 5. Okay. The sum has to be 5. S equal to 5. How it works is, I'm going through the recursion part. First, it will be like all the 4 elements there for one. So it calls the subset sum again with the value of L without 1. Not the first element, just that element, the ith element. Okay, but I removed the, I minus 1 from the sum, so it will be 4. Then the sum should, in some combination, here the sum should give 4. So for here, it will go like a 3, 4. The sum should, I'm giving a comma, 4. Should be 4. Then it will be like a -1. 2 minus 3 minus 1. So it's false. So it will return a false because S cannot be a negative value here in this case. So it will return false. Then going back, so then 4, 3 minus 2, yes, cannot be a negative value. So it is again false. This will not work. This will not work. Then here I am taking like a 2 and 4 because I removed 3 and 4. I subtracted that 3 from 4, then it will be the same case. This both will not possible. How we know? Because both are greater than 1. So any combination will not be possible. So even if I 2, it will take 4 and it will be like a -1. It will not work. If I take 4, 2, it will be like -3. It will not work. So the next combination. Then, so these two all satisfy. These two are satisfied. Then the 4, 2, 3. 4, 5. Four minus 4 is 0. Okay, then it will return true. Okay, once it returns true, it come back and return true. So I'm not calculating anything more. So how it come back is, so 0 is true. So it will return back this function, right? Subset sum to true. It will return true. I mean, in this case, it is R. I can directly return subset sum also. Okay, that's also easy way. If I want to take that value, so I am returning R. So then if I R is true, it will return true. Then this true will go to that part. here. It will evaluate a true, so it will be returning true up to the this value, the final first level, this value, and it will be true. Okay, how I calculated the thing is just see the value. I took the 1. Okay, then the positive part where we got 2, right? 1 plus 4, which is the sum 5. Are you able to follow? Any comments?
It is difficult to understand actually.
Yeah, I mean, I agree. I mean, especially with the far part, it's really difficult. I mean, even I
Yeah.
struggle a lot. I totally agree with you. Okay, I spent like a hours just to solve it some which involves this far, like.
Even with paper and pen, like not only in head, in even with paper and pen, it is also very.
Okay. I mean, these are like a practice problems. Okay, so you don't want to. It won't be that much. I mean, if when it will come to PDSA, right, this much problems are really expected from you. But in a Python, you should be proficient with the basic recursion. That's all.
Yeah, basic recursion is fine. Like
I mean, you won't be asked like this much difficult problem in the exam or like that. Okay? So I mean, it is really difficult. Okay, it will take a lot of time. But when you come to PDSA, it is the basic level you will be expected. Okay, so that is when you come to PDSA. So
yeah.
I mean, don't worry about that. If you are able to do Fibonacci sequence and the simple sum using the recursion and able to understand what is really happening, what is the control for all those things, right? That is sufficient. I mean, for Python course, that is sufficient.
Yes.
Okay. So don't worry about that. I mean, just the thing is go through line by line and know what is happening. Okay. The thing is here, okay, I'll explain once again. And the last time, what we did is, let's say, what I did is, I took one element, I removed that, and I'm do something with the, I'm passing the rest of the value, and did the same, right? At the end, I found something or like that. But here, the thing is different. I took one element, and I give some value, and I want to, each will go in a different way. It will have like 2 ways, it will have 2 ways, it will have 2 ways. Same way, one have 2 ways, like these two, yeah, it have multiple ways. So it's more like a combination we are calculating. 2 have 2, so 2 have 3 ways. Similarly, okay, these are the branches for the last thing we have seen. At some branch, we have to reach 0. I mean, it can be any node. I mean, it can be at the end, at the beginning, or at the. But what we have seen on the first problem, right? I mean, the initial, it won't branch out like a lot. I mean, Fibonacci branch out somewhat, at least it will have constantly 2 branches, but it will have like a branch based on the length of the list. Let's say sum, it will not branch out, it will branch out only one. I mean, let's say I'm going with the last element. Okay, 4. That's all. What you can see here, right? How it is going. It's only one branch.
Yes.
Okay, there is not much many branching. That branching is done by the for loop. The for loop does that branching. Okay. You understood the point, right? I mean, why for loop? Why for loop is here? I mean, some loop is recorded here. Any doubts? I mean, at the end, you are able to understand what generally recursion is, right?
Yes, sir. Recursion is fine.
Okay.
Sir, so actually, for week 8, I have to go through some of the topic also. I have not completed. So if I face any problem, I'll post in Discord as well as in the next session.
The easiest, the important thing is you have to print the statement. Okay? Whenever you're writing any recursive code, right? Print the value of the argument. It's not a recursive code, but you have multiple argument too. The easiest way to, I mean, imaginately or instead of doing our mind in, imagination in the head, we can get the values. Just print the value of argument 1, argument 2. Okay. Now you can know how it is changing. Then the same recursive function will be executed some manipulation or like that. Let me return. The easiest way to visualize is just print the arguments. Then print the relevant parameters you have.
Yes.
Okay. Then you know what is happening. Also, if you want to calculate something globally, right? Assign a value outside, and if you want to know the level, then increment it and include it here itself. So by this way, you know how much and what is the level of recursion you are going to. So visualize the recursion. Start with a very small problem, approach slowly. Don't worry about the harder problem, anything at all. Just start with a small problem, understand completely, okay? Totally understand what's happening there, then move on to the next problem. That's the perfect way.
So it is like adding more and more layers.
Yes, absolutely.
Yeah.
We'll be going deep on some recursive path, and we'll come back with some results. The result is either I succeeded or failed. Okay, I'll try another case, kind of like that.
Yes.
Okay.
So another thing, not from recursion, one general query actually. In term 1, city, lots of emphasis was given on graph, nodes, all those things.
Yeah.
But here in Python, not so much emphasis was given on matrix was there, but not on too many emphasis on graphs and nodes. So
Okay,
are
I
those
mean,
things?
the graphs and also the whole graph theory thing, right? You will be studying a lot in PDSA.
Okay. Okay.
Okay. I mean, Python is like in CT, you'll be reading the pseudocode. Okay, you understand the logic, but in Python is all about writing your, converting your logic into code.
Okay.
In CT, you'll be learning logic. You after completing CT, you can understand. Okay, this is the pseudocode. This is the logic. That is the expectation at the end. From a student who are completing the CT course. Okay. From the Python course, your logic is tested surely, but more emphasis is given for the how you are converting into a code.
Yes.
Yes, that is the emphasis, and that is the main expectation from a Python course. Once you complete the Python, right, that is the expectation from the student. From us, the student should be. The thing is, it can be like you don't need to be efficient. Okay, your code can be like a very slow, or it's totally fine. The thing is, you should be able to solve the problem. That's all.
Yes.
Yeah, you will deal with the efficiency when you come to a PDSA course. Don't worry. Here, you have to solve the problem. How can you solve it?
Yes, sir.
Okay. Anything else?
No, sir. If I stuck in any problem, I'll post in Discord as well.
Yeah. Sure. Yeah. Okay, then we'll wind up the session. Yeah, thank you all.
Thank you, sir.